Last year, Angular and React were effectively the same framework. I know, you might be thinking, this is ridiculous, makes no sense. Angular uses classes and templates, and React uses functions and TSX or JSX. How could that be even remotely true? Well, even though we use very different types of syntax in each one of these frameworks, under the hood, last year the frameworks used to function very similarly. And there was one thing that caused divergence between them that we're going to discuss today. My name is Minko Gechev. I'm the product lead for Angular at Google, where I'm also working on converging Angular with another internal framework called Wiz. You're going to learn about it in just a little bit. Today, I'm going to share with you how frameworks might be more similar under the hood that you would anticipate. And also, you're going to learn on a couple of major trends in the front-end space. And I'm going to make a prediction on what we could be potentially converging next. So let's go back to Angular and React again. In both cases, we're going to develop our components with absolutely different types of syntax. In Angular, we're going to use classes and templates. In React, we're going to use functions and TSX if you're using modern React. From there on, the framework is going to take these components at runtime and build a component tree. And the framework is going to make sure that when the data in our application changes, it updates the view. That's exactly the part where Angular and React were actually very similar a year ago, until something happened. In both cases, we would somehow notify the framework that the state has changed. From there, the framework is going to traverse this entire component tree to figure out what has changed and reflect the changes in the view. Let us look at a very simple example. Here we have an Angular application using Angular syntax because, well, that's the framework I'm working on. So more familiar with its syntax. We have the app component that has the user profile component and a shopping cart component inside of it. In the user profile component, we just display the username. And in the shopping cart component, we just iterate over a list of items in a cart. And for each one of them, we display the quantity. That's it. From here, the framework is going to build the following component tree. We have the app component at the root, we have the user profile component on the left, and we have on the right the shopping cart component. So let's suppose we update the first item in the shopping cart. In this case, the framework is first going to check whether anything changed in the root. After that, the framework is going to go to the left child and verify whether everything is still the same in the user profile component. And finally, it is going to go to the shopping cart component and figure out that the actual change that happened is actually only affecting this single component. In both change detection of Angular and reconciliation, the algorithm will be very much the same. So we perform two unnecessary visits of nodes just in order to verify that nothing really there changed. In both Angular and React, we can optimize that very much using the same approach, different syntax, but under the hood, the frameworks are using very much the same tree pruning algorithm. In Angular, we can use onPush, and in React, we can use memoization. When we specify in the cart that the quantity of the first item is 1, and we're using onPush or memoization, we could only visit the root component and the shopping cart component. So this way, we're going to skip one whole component subtree. In this case, the user profile component. But we still perform a necessary traversal. Now, if you're not convinced yet that Angular and React are more similar than they appear, or they were more similar than they appear, we can look at framework benchmarks. This here uses React hooks, version 18, and Angular version 17. This was before Angular introduced its new control flow syntax, which significantly improved these benchmarks. In both cases, we can see that we have very much the same performance pattern here. Both frameworks are doing pretty poorly with swapping rows, and they have pretty fast partial updates. Now let's go back to our previous example here. We have this pretty small component tree. So in order to verify what's changed in it, we'll just have to traverse 3 components at most. which probably doesn't seem like a big deal, right? Whether we traverse 1 or 3 components, basically the same thing. But real life applications are very different. We often have hundreds or even thousands of component instances on the page at a given point. So if we have to traverse every single one of these components one by one every time when the state might have changed, this could slow down significantly our apps, and it could cause some user experience regressions, which would be pretty unfortunate. We can start dropping frames and provide suboptimal user experience. That is why Angular started evaluating what can we change to remove all these redundant tree traversals. And that's exactly when we decided to adopt signals. Signals is this reactivity primitive that is used by Vue, Angular, Solid, Svelte, Ember, Preact, and others. React decided to adopt a slightly different approach. You might be thinking, yeah, the React compiler is doing the exact same thing. Well, the React compiler is an amazing engineering accomplishment. It is a really solid piece of software, but it does something else. Instead of being extremely precise about what might actually have changed, which it does really well as well, by the way, it also separates the view in static and dynamic parts, which is very similar to what the Angular compiler does as well. Of course, in the React compiler, you're going to get a couple of more benefits, which are going to reach good amounts of fine-grained reactivity, probably not as fine-grained as you would achieve with signals. With signals, you declare a signal, and you just read it in your template. And from here, just by reading the signal, we notify the framework where exactly this signal has been used, so that when you update the signal value, the framework can go to this exact component and this exact part of its component tree and update the value. Now, if we look at our more complicated example here with the hundreds of components, if we update the quantity of the first item, and this item here is a signal, instead of traversing the entire component tree, we'll just have to go to the individual components that have read the value of this quantity. And this way, we're going to prevent performing unnecessary traversals. That's pretty cool. Now you can see that signals, they gained significant traction in the JavaScript community. They've been also getting traction inside of Google. In Google, we have Angular and a framework called Wiz. Wiz is, you can think about it as Eleventy or Astro to an extent, or Quick. In fact, Wiz invented resumability that Quick adopted about 2 years ago. And Angular and Wiz have been used for different kinds of products. But overall, we noticed that developers using Angular, they wanted some of the performance features of Wiz, and developers using Wiz wanted some of the developer experience features of Angular. So that's how we started collaborating together. I was assigned to figure out how we can potentially converge these two frameworks into one. And I joined the leads group of Wiz. By looking at their chat one day, I noticed that they were working on supporting YouTube. That's the second biggest website in the world, in improving their user interface story. And they were planning to do that with signals. At the same time, though, Angular was already actively developing Angular signals and figuring out the Angular reactivity story with signals. So I decided maybe here we can collaborate. And this is how we started using Angular signals in YouTube with Wiz. After YouTube started using Wiz with Angular signals, they noticed 35% better input latency on low-end devices compared to their previous legacy virtual DOM implementation. They also noticed 60 frames per second swiping on low-end devices in YouTube mobile web shorts compared to their previous jitter implementation. And they noticed significant increase of engagement as well. So seeing that signals were very successful in Angular and they're very successful in this converge story of Angular, we decided that potentially we could make them a thing in the broader JavaScript ecosystem. So we gathered together framework authors from Ember, Vue, Svelte, React, and other frameworks into the joint effort to make signals part of the JavaScript language. This has been pretty exciting because the reference implementation for signals originated from Angular signals because they proved to be scalable and also to be versatile, used by 2 frameworks already. Now, I know merging 2 frameworks sounds like a really big deal, and it actually is. I'm not aware of anyone who has done that in the past. But the way we think about it is just taking the best from each one of these frameworks into the other until they eventually converge. And we'll be doing that by seeking opportunities to open source primitives and share them as industry best practices. I'll say that that's exactly what we did with signals. By converging these 2 frameworks, we notice very similar concepts in all the frameworks out there. A lot of similarities in reactivity, authoring experience, event handling. Pretty much every single framework there has some version of dependency injection as well. And I know you're thinking, no way, React does not have dependency injection. Some people might be thinking also, no way, Angular does not have a context API. What if I tell you that Angular's dependency injection and React's context API are in fact serving very much the same purpose, and they have very much the same hierarchical structure? So frameworks are not that different, and there are a couple of deviations. One of them, as I mentioned, between Angular and React occurred thanks to the fine-grained reactivity that Angular implemented with signals. All right, converging to different frameworks sometimes can create concerns around stability. So this is something that we have been really heavily investing in Angular for a while now. Every single change that we do in Angular goes through a pull request, and we have over 27,000 pull requests to the Angular repository that we have handled so far. Most of them merged, the vast majority of them, I'll say. And each one of them goes through over 20 different checks. Of course, size regression tests. We have different tests for units tests, end-to-end tests, different snapshot tests, and so much more. But probably the most impactful one that is extremely unique to Angular is the so-called Google internal tests, which means that every single change that we push to GitHub goes through internal tests. So all the hundreds of thousands of tests that are dependent on this change in Google are going to let us know if this change was backward compatible or not. If we break something, we need to fix it, which means a lot of pain for the Angular team. But at the same time, it means unmatched backwards compatibility. So this is what makes us very confident in the stability of Angular. Now, I would like to finish this talk with a prediction about another thing that frameworks will be converging on in the future. And in my opinion, this is event replay and fine-grained code loading. Now, in a traditional application, which is not optimized using client-side rendering only, the user is going to navigate to a URL. The server is going to respond with some HTML. There is going to be some reference CSS and JavaScript that the browser will have to download from the server. From there, we have to execute the JavaScript, and we're going to fetch some data, and finally we're going to render something onto the screen. And this could take forever. There are optimized versions of this. We can add server-side rendering to, instead of just returning some basic HTML and having to render the initial version of the page after we fetch data, we can do that on the server and immediately push the rendered content. But we still have an interactivity gap. Since we render to the moment in which we execute the JavaScript and attach all the event listeners, there is nothing going on the page. Like, if the user starts interacting with the page, just there will not be event handlers to handle these events. And this interactivity gap, at Google, we have been handling it with something called event replay. So here is a very simple mock. When it is gray, this means that the page is just not interactive yet. When it is blue, means that the page has gotten interactive. See, when I start clicking on the Add to Cart button, nothing happens. but when the page becomes interactive, I get 4 items in my shopping cart. This happens because when we load the page, we load it with a very small, very thin layer of JavaScript that records events. And once we download the functionality responsible for handling these events, we just replay them. This is a feature, as I mentioned again, called Event Replay. It is available in Angular today, in developer preview for the next couple of weeks. We're going to graduate it to stable. And it is powered by an abstraction called Event Dispatch that has been used in Google search for over 10 years now. We modernized this version and we put it in the Angular repository. So if you're interested in what has been handling your events when searching things on Google, just head out to the Angular repository and find Event Dispatch. This collaboration between Angular and Wiz has been also leading to some inspiration. Now, Angular introduced this concept of deferrable views, which have great client-side semantics. We download code only when it is necessary. But in Wiz, we have resumability, which is a really powerful concept that enables us to lazily load code and download only the code that is responsible for handling certain user interaction. Now, very inspired by this concept of resumability and working closely with the Wiz team, we have been experimenting with something called incremental hydration. So when we send the request from the clients to the server and we get the rendered page, here we can have different deferred views or different incrementally hydratable regions on the page that have been specified with this defer block. When we load the application, none of this JavaScript is present, which means that we significantly reduce the total blocking time and from there have better core web vitals. When we start interacting with a particular component, let's say in this case a navigation, we're going to download the JavaScript associated with this component and hydrate it, make it interactive, and replay the user event. Now, we have been exploring one more thing here. What if the site navigation uses a signal, modifies its value, and its value is used in another component, let's say in the top bar component? It is entirely possible to serialize the signals graph, and when we update a signal that is used somewhere in the top bar, hydrate the top bar as well and reflect the value. This is not part of the initial implementation, but we were very interested to see whether you have use cases for that and how important this feature is for you so that we can consider implementation and add it to future versions of incremental hydration. All right, now I covered a lot of stuff here. I talked about reactivity, event handling, and dependency injection, and I haven't even scratched the surface. There is so much more in one web framework. But hopefully you saw that frameworks are very much converging on similar concepts. And Adios Manny shared in his JavaScript Meta Frameworks in 2024 talk at I/O that frameworks are often sharing also very similar features. Now I updated this chart a little bit to reflect my own views, but you can see that we have all of the frameworks being component-based. We have very similar server-side rendering support. We have pretty much shared reactivity story across most frameworks. So how do you even pick a framework? Well, when picking a framework, just don't overthink it. You end up using the same technology with just a different facade. But when I pick a framework for a production website that I know I'm going to maintain for the years to come and my income depends on it, I'll usually pick a framework that is stable and reliable. A framework that has a supportive community and a rich ecosystem, and a framework that I enjoy using. That's everything I had for you today. Thank you very much for listening to my talk, and happy coding!